Imagine a mind so curious, so relentless, that it couldn't help but peer into the deepest mysteries of the universe. Some of the greatest physicists and thinkers have asked questions that didn't stop at the boundaries of the known, but pushed into the vast, dark unknown of space itself. Their work has changed the way we see the world. But when attention turns to the cosmos, what is found is more than just fascinating. It is in some ways deeply disturbing. To understand why, let's start with the kind of questions that drive scientific discovery. True curiosity isn't satisfied with surface-level answers. It wants to know why things are the way they are and what happens when you dig beneath the surface. For those who see the universe as a puzzle, every answer leads to more questions. And nowhere is that puzzle more challenging than in the vastness of space. In the mid-20th century, as humanity was just beginning to send rockets beyond our atmosphere, scientists were already thinking about what lay beyond the stars. They were fascinated by the fundamental forces that govern the cosmos: gravity, electromagnetism, the strong and weak nuclear forces. But they were also haunted by the gaps in our understanding, the places where the laws of physics seemed to break down, or where the math just didn't add up. One of the first things that disturbs anyone who studies the universe is the sheer scale of it. Space isn't just big, it's incomprehensibly vast. The distances between stars, the emptiness between galaxies, the unimaginable number of planets and suns. On a cosmic scale, Earth is less than a speck of dust. Our entire history, every human achievement, is dwarfed by the size and age of the universe. This realization is both humbling and unsettling. It forces us to confront our own insignificance, to ask what it means to be human in a universe that is so much bigger than we can imagine. But the questions go deeper into the very fabric of space itself. What is found there is even stranger. According to quantum mechanics, empty space isn't really empty. It's a seething foam of virtual particles popping in and out of existence, governed by the uncertainty principle. This quantum vacuum is full of energy, even in the absence of matter or light. Theories like quantum electrodynamics, describing how light and matter interact, show that the vacuum is alive with activity, a restless sea of possibilities. This idea is disturbing for a couple of reasons. First, it means that the universe is never truly at rest. Even in the coldest, darkest reaches of space, there is always something happening at the quantum level. Second, it raises profound questions about the nature of reality itself. If empty space is full of energy, could we tap into it? Could it be the source of mysterious phenomena like dark energy, which is causing the universe to expand at an accelerating rate? Calculations hint at these possibilities, but the answers remain elusive. Then there's the problem of the cosmological constant. When physicists try to calculate the energy of the quantum vacuum, they come up with a number that is staggeringly large, so large, in fact, that it would have torn the universe apart long ago. But when astronomers measure the actual expansion of the universe, the cosmological constant is tiny, almost zero. This mismatch is one of the biggest unsolved problems in physics, and it deeply troubles scientists. How could the math be so wrong? What are we missing about the true nature of space? There's also the question of life in the universe. Given the vast number of stars and planets, it seems almost certain that life must exist elsewhere. But if that's true, where is everyone? This is the famous Fermi paradox, and it bothers scientists as much as anyone. Are we truly alone, or is the universe teeming with life that we simply can't detect? Or is there something about the nature of intelligence or the dangers of cosmic evolution that makes life rare and fleeting? Perhaps the most disturbing thing found when looking deep into space is the ultimate fate of the universe. The laws of thermodynamics suggest that over unimaginable timescales, the universe will suffer heat death, a state of maximum entropy where all energy is evenly distributed, and nothing interesting can ever happen again. Stars will burn out, galaxies will drift apart, and the cosmos will become cold and dark. For any curious mind, this is a chilling prospect. A universe that ends not with a bang, but with a whimper. Let's continue the journey into the unsettling mysteries that space reveals when we look too deeply. The more we learn, the more we realize how much remains hidden. and how the universe seems to guard its secrets with paradoxes and puzzles that challenge even our most advanced theories. One of the most perplexing discoveries is the existence of dark matter. When astronomers observed the motion of galaxies, they noticed something strange. The stars at the edges of galaxies were moving much faster than expected, as if there was far more mass present than what could be seen. This invisible mass, now called dark matter, doesn't emit or absorb light, and it doesn't interact with ordinary matter in any way we can easily detect. Yet it makes up about 85% of the matter in the universe. We know it's there because of its gravitational effects, but we have no idea what it actually is. Countless experiments have tried to detect dark matter particles, but so far, all have come up empty. The universe, it seems, is built mostly from something we cannot see or touch, a disturbing thought for anyone who believes in the power of observation and measurement. Then there's dark energy, an even more mysterious force. In the late 1990s, astronomers discovered that the expansion of the universe is not slowing down, as everyone expected, but speeding up. Some unknown energy, spread throughout space, is pushing galaxies apart at an ever-increasing rate. This dark energy makes up about 70% of the total energy content of the universe. Yet we have almost no understanding of what it is or how it works. The fate of the cosmos depends on this invisible force, and yet it remains one of the greatest enigmas in all of science. The more we look, the more we find that the universe is not only stranger than we imagine, but stranger than we can imagine. Black holes are a perfect example. These are regions of space where gravity is so intense that nothing, not even light, can escape. At the center of a black hole lies a singularity, a point where the known laws of physics break down completely. Time and space themselves become warped beyond recognition. If you were to fall into a black hole, you would be stretched and compressed in ways that defy all common sense. Even more disturbing, information that falls into a black hole seems to disappear from the universe, challenging the very foundations of physics, which say that information must always be preserved. Cosmic inflation is another mind-bending idea. According to this theory, the universe underwent a brief period of exponential expansion just after the Big Bang, growing from subatomic scales to cosmic proportions in a fraction of a second. This explains why the universe looks so uniform on large scales, but it also raises new questions. What caused inflation? What existed before it? And could there be other pocket universes, each with their own laws of physics beyond the reach of our observations? The possibility that our universe is just one of many in a vast multiverse is both thrilling and deeply unsettling. Even the nature of time itself becomes questionable when we look too deeply into space. The theory of relativity shows that time is not absolute. It can stretch and contract depending on gravity and speed. Near a black hole, time slows to a crawl. At the speed of light, time stands still. The arrow of time, which seems so obvious in our daily lives, becomes blurred and ambiguous on cosmic scales. Some theories even suggest that time could run backward in certain conditions, or that the past, present, and future all exist simultaneously in a block universe. These ideas challenge our most basic intuitions about reality. And then there's the question of the universe's beginning. The Big Bang theory describes how the universe has expanded from a hot, dense state, but it doesn't explain what caused the Big Bang or what, if anything, came before it. Some theories propose a cyclical universe, endlessly expanding and contracting. Others suggest that our universe was born from a quantum fluctuation in a larger multiverse. Each possibility is more bizarre than the last, and none offer a satisfying answer to the ultimate question. Why is there something rather than nothing? As we peer deeper into space, we are confronted not just with new knowledge, but with new mysteries, mysteries that seem to multiply the more we learn. The universe is not a tidy, predictable machine, but a vast, dynamic, and often bewildering place. The more we discover, the more we realize how much remains unknown, and how the answers we seek may always be just out of reach. Let's keep exploring the unsettling truths that emerge when we look too deeply into the cosmos. As our telescopes and detectors become more powerful, we're not just filling in the blanks of our cosmic map. We're uncovering new questions that shake the very foundations of what we thought we knew. Consider the cosmic microwave background, the faint afterglow of the Big Bang. This ancient light, stretched and cooled over billions of years, is a snapshot of the universe when it was just 380,000 years old. By studying tiny fluctuations in this background radiation, scientists have learned about the universe's age, composition, and even its shape. But the more closely we examine this cosmic relic, the more anomalies we find: strange cold spots, unexplained alignments, and patterns that don't quite fit our models. Some researchers wonder if these oddities are clues to new physics, or even evidence of other universes brushing up against our own. The idea that our universe might be just one bubble in a vast cosmic foam is both exhilarating and deeply disorienting. Another disturbing realization comes from the concept of cosmic isolation. As the universe expands, distant galaxies are moving away from us faster and faster. In the far future, most galaxies will slip beyond the cosmic horizon, receding so quickly that their light will never reach us. Eventually, only the closest galaxies will remain visible, and the rest of the universe will fade into darkness. Future astronomers, billions of years from now, may have no evidence of the Big Bang or the wider cosmos. The universe will seem smaller, lonelier, and more mysterious than ever. This cosmic isolation is a sobering reminder that our window into the universe is temporary and that some knowledge may be lost forever. Let's not forget the quantum strangeness that underlies everything. Quantum entanglement, for example, allows particles to become linked in such a way that the state of one instantly affects the state of another, no matter how far apart they are. This spooky action at a distance defies our classical understanding of space and time. Experiments have confirmed that entanglement is real, but no one fully understands how it works or what it means for the nature of reality. Some interpretations suggest that information is shared non-locally, hinting at a deeper level of connection in the universe that we have yet to comprehend. Then there's the unsettling possibility that the universe is fundamentally unpredictable. Quantum mechanics tells us that at the smallest scales, events are governed by probabilities, not certainties. We can never know exactly when a radioactive atom will decay, or precisely where a particle will appear. This inherent uncertainty isn't just a limitation of our instruments, it's built into the fabric of reality itself. The universe at its core is a place where chance and randomness play a fundamental role. For those who crave certainty and order, this is a deeply disturbing thought. The search for extraterrestrial intelligence adds another layer of mystery. Despite decades of scanning the skies for signals, we have yet to find definitive evidence of life beyond Earth. Some scientists suggest that intelligent civilizations may be extremely rare, or that they self-destruct before they can make contact. Others propose that advanced life is out there, but is choosing to remain silent, or is simply too different for us to recognize. The silence of the cosmos, known as the Great Silence, is one of the most profound and unsettling mysteries we face. Are we truly alone, or are we just not listening in the right way? Even the constants of nature, the numbers that define the strength of gravity, the charge of the electron, the speed of light, raise disturbing questions. Why do these constants have the values they do? If they were even slightly different, stars might not form, chemistry might not work, and life as we know it would be impossible. Some physicists wonder if these values are the result of chance, or if they are set by deeper laws we have yet to discover. The possibility that our universe is just one of many, each with its own set of physical laws, is both awe-inspiring and unsettling. As we continue to look deeper into space, we are forced to confront the limits of our knowledge and the possibility that some mysteries may never be solved. The universe is not just vast in size, but in complexity and strangeness. Every answer leads to new questions, and every discovery reveals new layers of mystery. The more we learn, the more we realize how much remains unknown, and how the universe, in all its beauty and terror, will always keep some secrets hidden in the dark.